the way we drive our work, there has to be some things that really you care and value for. So for our work, these are the 5 values that drive us and our projects and our spirits. I will touch on that towards the end, will not speak about each of these values. Once you have the values that you really commit to, but working on a larger scale projects across different locations, you need a framework to deliver consistency. And we have developed a unique framework which is called 10 metrics. They are listed here, and you will witness these metrics drive our work. And there's a book published by American publisher on 10 metrics. I would encourage you to check out. Once you have the metrics, that is not enough. Collaboration is key to deliver large, complex, meaningful projects. And especially now it's even more important when the boundaries are blurring between what is local and what is global, and what material and what technology to use. So collaboration is key, and research collaboration drives our practice. And there is another book published by Mappin, talks about our collaborative work practice and some of the case studies available globally. I would encourage to check that. As far as the expertise that we bring across sector, we have expertise to offer for any type of a project in the built environment. So this just quickly lists what sectors we cover, and the numbers are last 15 years what we worked on and delivered in this region. This is a footprint of our work and our locations in terms of office across globe. As in the introduction said, we started India South Asia as a Burt Hill North American brand, merged with Stantec, and reintroduced, restructured our practice for India South Asia as I&I Design Studio. And we have all in-house expertise to offer as listed here, and the locations. So that's quick round of I&I. Earlier we have been talking in last decade plus sustainability and green and so forth, and we have been bombarded with those terms. Now it's net zero that we hear a lot, right? So when we talk about a material, technology, or a system, I think for today I thought let's just connect the steel and the net zero story in a more meaningful way. So I just happened to see that, okay, what's the relationship of Bharat and steel, right? In English you just have 3 same words, but in Bharatiya language it's Ispat, Folad, Loh, and there are few more. And steel and related concepts were mentioned in various early Vedic terms, which we are not really today aware of that. So I thought just remind ourselves that it's not new to us, right? We were pioneer, and it's just we are just reinventing it today. We all know what is steel and what is it made of, right? Now, being a designer, architect, फॉर एनीथिंग दैट यू यूज एज अ रिसोर्स, उसका नेचर जानना बहुत जरूरी है, प्रकृति जिसको बोलते हैं ना. एनीथिंग दैट वी वांट टू यूज, वेदर इट्स अ रिसोर्स, लाइव और जस्ट अ मटीरियल, प्रकृति को अगर जानेंगे, then we will really use that in a more meaningful way. So Prakriti of steel, we all know, but I have listed it, that what really steel offers and what is the nature of the steel as a material. CO2 materials जो कंस्ट्रक्शन में कॉमन है, पर क्यूबिक मीटर from 48 kg of a CO2 per cubic meter all the way to 18,000 kg of a CO2 per cubic meter. So this is very important. As we know the prakriti of material, what is their CO2 footprint now has to be put in our mind, right? When we talk about steel, और कंक्रीट से तो कार्बन फुटप्रिंट बहुत ज़्यादा है, सीधा वो दिमाग में आ जाता है आजकल डिस्कशन में. सो आई थॉट लेट्स नॉट जस्ट डू हाफ हार्टेड और हाफ ट्रूथ डायलॉग्स. स्टील इज 3 if it is virgin, if it is recycled it's 1 kg, and if it is galvanized it's 1.85. We need to ask the next level questions to align with the data that we really deal with. In terms of industry, steel is about 7.2% of the total emission globally, right? And the bottom number, 73%, is the overall CO2 footprint of energy that is being produced across sectors. Building industry, 17.5% of the overall CO2 footprint. Just getting the facts in our head is very important. Cost of CO2, I don't know if you are familiar with this terminology nowadays. In Indian context, it's $86 per ton. The social cost of CO2 emission for India. If you talk US, it's 150. Every country has a different cost associated, which is a social cost of carbon emission as a country. Steel and concrete story. So reinforcement steel 3.5 kg to 6 kg per square feet is generally what we hear about कि per kg कितना यूज कर रहे हैं हम. अगर 2000 स्क्वायर फीट का अगर रेसिडेंशियल प्रोजेक्ट की बात करें, बेसिक इंफॉर्मेशन, अबाउट 20 टन CO2 की बात कर रहे हैं हम. कॉस्ट ऑफ दैट इज $1,700. We don't pay this, so we don't think about all this, right? That's the only difference. Cement, 1.8 tons of a CO2 per ton of a cement, right, which is equivalent to galvanized steel CO2 footprint. तो 2000 स्क्वायर फीट का हाउस अगर रेनफोर्स कंक्रीट का करे तो सीमेंट की जो यूज़ है उसके हिसाब से उसकी कॉस्ट बताई है in terms of a trees planted. ऊपर का है 250, नीचे का है 680 trees we are talking. 2000 स्क्वायर फीट के घर की बात कर रहे हैं. There are a lot of these calculators available. एक tree about 18 inches का अगर girth है, 25 trees is 3 tons of carbon, which is 1 ton of a steel. Trees की comparison में देखें तो, right? And it talks about lot of other oxygen people breathe and so forth. Steel demand in India is growing, as we all know, thanks to all of the growth in the steel industry. But we need to be mindful and conscious all these previous numbers that what we mean when we talk of any industry in a built environment. Challenges of steel and potential of steel, I think we all know. I won't read everything, but I thought just list what steel brings to us and what are the challenges in Indian context. I think most of you probably have been talking one or the other way about this. One more case study, reinforced concrete versus steel structure. There are 4 case studies that part of this, SS1, SS2. They are steel structures. 4 projects, similar size, similar scale, RC1 and RC2 to reinforced concrete. The study analyzes entire life cycle carbon footprint of all 4. In the chart, bottom line, the RC building energy consumption during the life cycle versus the steel building, structural steel, structural RCC I'm talking. So from that angle, steel structure is about 40% if it is virgin steel, higher for this case study. And emission by building materials is listed here. As I said, it's about 40%, but that should not really be the focus. 40% to steel use nahi karna, which is the wrong mindset. Again, prakriti of the material and what is that you are trying to do in the project has to drive the decision of the material. And I will show how. First case study. This is a project that we have been working since last 4 years, 4 or 5 years, I would say. Entire master plan of a science city, one of the India's largest science city being developed by Gujarat government here in Ahmedabad, about 200 plus acre location. We master planned the entire science city and we have been doing several projects, building projects within this. This was the site when we started the project. This is the entire master plan. This is the project phased manner being implemented. So you can see a lot of new things have come up on this. And I will talk about the aquatic gallery and the steel story. So this is the aquatic gallery and the robotic gallery and all other science galleries around that. Key features of the project. Today I'm not talking the project features because the covering has to be focusing on steel. So I will focus more on steel and not on the design. So hopefully you will be okay with it. What drives the design? Again, the discussion is not about architecture but about how steel being introduced on this project, so I will not. The inspiration of the architecture and the overall final form that came up, how the design evolved in terms of the project. Largest aquarium of India. The challenge here is that it holds water and a live species as an exhibit. So material selection is the key in terms of what materials are being used A lot of live species across globes have been used. The plan here, we have used all three structural technology, whether is exposed, architectural, concrete, steel, and composite, all three. Just a floor plan, how the exhibits are laid out, overall structural overlay, and so forth. The sections, God is in detail, as I said. Every exhibit tank has been detailed out to the last minute because it's a live environment where the species needs to thrive. So we worked into these details, whether it's the exhibit or the steel structure. Okay, structural system. All three being used: exposed, architectural, concrete, quantities, their carbon footprint, number of trees, what does it mean, what we have used, and CO2 emission cost. And then now we are doing that with every project, because till you don't really register this number, we only talk first cost. Life cycle cost analysis is very key. Structural feature in terms of all three. Epoxy coated reinforcement is being used because a lot of water is being carried in this building. Talking about the steel, how it really helped creatively as well as efficiently. About 24-meter span. The main feature of the building, atrium, where the largest holding of people is being done. So atrium, height of a truss is 7 meters. Weight of each truss is 15 ton. Length 27 meter. Thickness of the top plate 16. And the entire building is 42 meter in radius. And again, in terms of the atrium, how it was erected in terms of crane being used. Entire atrium was erected in 30 days, which in any other material, if we would have done, probably would not be possible. Total weight, we analyzed different systems and still was the obvious answer there also, that what is the optimum structural system you could use. Construction during photos. The scale you can see, if I can point here, you will see some human figures in the center. So the scale of the truss is enormous. Lot of, as earlier discussed, a lot of special expertise is required to detail such building. Every joint, every connection has to be drawn, detailed, and modeled. And we have taken the north light also across these trusses within this atrium. And fireproofing also was a big task to really execute. Similar way, the monumental canopy, 26-meter span in one direction. This canopy is supported not just horizontally. 22 different points at different heights support this canopy. Very, very complex because the entire structure is all three-dimensionally curved. Again, a lot of challenge in terms of execution. 3 cranes have been using. This is the overall during construction. The canopy just sits on the edge. Entire canopy has been constructed fully as one piece and lifted and put on a place. You can see tunnels. Another structural system which is not the topic of the day, but I thought it's very important piece of information, acrylic glass structural tunnel being holding 22 lakh liter of water and largest panel of structural acrylic glass being installed. So structure system of such things are very complex that were used, a lot of drawings of the glass and so forth, a lot of RC work because the tanks have been designed with RC and the overall exposed RCC work going on. The scale you can see, this is just one slab of the entire project. And when the concrete was being used in a more meaningful way, a lot of detailing, and the fins have been also interesting, concrete detailing, aluminum formwork customized, lot of mock-ups have been rejected before the final for steel as well as for concrete, and the final product. Few more photos of the panel. This was inaugurated just 9 months back, maybe by our Prime Minister, Mr. Modi. So this is the canopy that I just described. Lot of exposed RCC concrete, architectural. This is the central atrium and some of the exhibit space, the tunnel. This is also part of the atrium on the right side. So lot of large span, and last but not least, the cafeteria. Similarly, another project quickly we'll go through because it's one of the unique steel installation that is currently going on there. This is the Astronomy Museum, where the center portion of the building is where the central planetarium is being used. Plan of that and the section of the planetarium entirely done with steel. You can see in some of those sectional drawings, again, all three materials have been used here also, and their data, structural features of all three. I won't read everything, but I will showcase the steel, which is the centerpiece, again in this museum. Very tall central space with a large span, and the total 18-meter diameter inside radius, outside is 22 planetarium. So this is the initial model and supported with just 4 points, and it's floating in the space. Lot of drawings, over about 2,000 connections and shop drawings, that every detail has been coordinated. Every junctions has been modeled in 3D and in structural calculations, and the sections are also bearing at every point. And currently, as we speak, the final erection is happening on this gallery. You can see the man in the center, so you will understand the scale what we are talking here. A lot of erection challenges and planning you could see, and it's being erected in sections. Now you can see the scale. final top connection, and when it will done, finished, it will look like this. So that's the outer skin of the planetarium. Total 22-meter span sphere. I will skip this project in the interest of the time because I want to cover the final thing. Concluding, should we just keep using still? When to use still? 8 things to know and consider: cost, climate, durability, availability, sustainability, maintenance, aesthetical aspects, and performance of the overall system that we use and how it contributes to the overall building's performance. So these are the 8 things that I think we need to really look at it before we say what material we use as a system. Still offers a lot of benefits and a lot of unique applications and ignites creativity with still free forms as I displayed here. So it allows those wonderful creations, but I would say that still needs to be weighing in all these 8 elements while we decide. Back to the values where I started. So, are we here to promote still? Maybe. The answer is we need to decide what is right to use. That's the first thing. And if answer is still, go for it, right? And still offers a lot of those, yes, in current time where we are building new country with a lot of infrastructure, large span, lot of buildings, where still offers a promise, I would say. And second is we are driven to achieve. When I say we, it's not just me, myself, or I&I team, it's all of us. And today we are in the time where if we work together collaboratively as one ecosystem, we can achieve what we aspire for our nation. Thank you all.